Hello everyone, I am Dr. Krishna Sarker. Here in this session, I'll be going to discuss about signal flow graphs or SFG. This is linear control systems lecture series on linear control systems, lecture number 26. So our new topics, signal flow graphs. Overview of signal flow graphs. What is the overview? Introduction of the signal flow graphs. Signal flow graphs terminology. Node analysis. What is branch of a signal flow graphs? Input nodes or source node. Output nodes or sink node. Chain node or mixed node. Dummy nodes. Path, forward path, and path gain. What is loop, feedback path, and loop gain? What is non-touching loops and self-loops and self-loop gains? These are all overview of signal flow graphs. So first, introduction of the signal flow graphs, then signal flow graph terminology. What is signal flow graphs? For complicated systems, block diagram reduction technique becomes tedious and time consuming. An alternating method is that signal flow graphs developed by S.A. Mason. In these graphs, each node represents a system variables and each branch connected between two nodes act as a signal multiplier. Suppose this is A node and this is the B node, and the gain multiplier G. So in this graph, each node represents a system variable, A, B system variable, each branch connected between two nodes. AB, one branch, acts as a signal because this is the direction of the signal and this is the direction of the signals. Then the direction of signal flow is indicated by an arrow. In SFG or signal flow graphs, there is a standard formula called Mason's gain formula. In block diagram, there is no straightforward procedure for finding the transfer function. So in signal flow graphs techniques, the standard formula, Mason's gain formula. But block diagram, there is no straightforward procedure for finding the transfer functions. Signal flow graphs, step 1. Signal flow graph terminology. Consider a signal flow graphs shown in figure 1. Shown in figure 1. Suppose R of S reference input and C of S output. Then another node A and the branch gain 1. A to B, the branch gain G2, and B to C, the branch gain or G4, and C to D, the branch gain G6, and D to C, the branch gain 1. This is the also forward path. Similarly, A to F, G3, F to E, G5, and next B to E, G4, F to C, G8, E to F, minus H1, C to B, minus H2. These are all nodes. A, B, C, D, E, F are all nodes. Signal flow graphs example. So definition, what is node? A node of a signal flow graph is a point representing a system variable. It is denoted by small dot or small circle. In this case, A, B, C, D. In figure 1, RS, A, B, C, D, E, F, and C are nodes. This is the node RS, A, B, C, D, E, F are nodes. Nodes are arranged generally left to right for input-output relationship. So this is the definition of nodes or basic idea of nodes. Then step number 2, input or source node. What is the input node or source node? RS is the input node or source node. This is also called excitation, and also this is called cause of the systems. And this RS may be step, ramp, parabolic, impulse, sinusoidal, any type of input you can apply. So RS is the input node or source node. But why this node is called source node or input node? So what is the definition of the RS or RS node or source node? A node with only outgoing branches, in this case only outgoing branches, and the branch gain equals to 1, is called an input node or source node. An input node represents a totally independent variable. It has no branch or branches coming into it. It may supply signal to several nodes. In figure, RS is the input or source node. So this is the basic idea of the input or source node and excitation node. This is the basic idea. Then step number 3, what is the output node or sync node? CS is called the output node. But why this node is called output node? A source which has only incoming branches. In this case, CS is the output node and has only incoming branches, no outgoing branch. Is called output node or sync node. Sync node totally dependent on other variable or signals. In figure, CS is the output node or sync node. This is also called effect node or effect node of the system. So this is the basic idea of the output node or sync node. Then step number 4, chain node, common node or mixed node. What is the definition of chain node, common node or mixed node? Chain node definition: intermediate node which has both incoming and outgoing branches are known as chain node, common node or mixed node. This is a very important, which has both incoming and outgoing branches. Suppose this is one node A. This is incoming and these two outgoing. So A node is called chain node or mixed node. In this case, figure A, B, C, D, E, and F are all chain nodes or mixed node, because for A, this is the incoming, and A to B, B to F are output or output branch, outgoing branch actually. So next step, step number 5, basic idea of dummy nodes. What is dummy nodes? Suppose A, one nodes and another nodes B, and the branch AB, the branch gain equals to G1. Then the feedback gain minus H1. Another branch G2 and the node C, and the branch gain, feedback gain C2B is minus H2. Dummy nodes for without input and output node. In this case, no input, no outputs. So this type of node is called dummy nodes for input without input and output nodes. And in this case, RS is the input and A feedback minus H1, B G2 minus H2, and the output C of S. So dummy nodes with input and output nodes. So what is the definition of dummy nodes? If the incoming and outgoing branches exist at a first and the last node representing input and output variable, such nodes are called the dummy nodes. Addition of branches of gain 1 is possible only before the starting node and after the last node. This is the addition node before the starting and after this node. So this is the basic idea of the dummy node. Next, step number 6, forward path and forward path gain. A forward path is a path that starts at input node and ends at output node. This is again a forward path is starts at input nodes and ends at output node along the direction of the signal flow. Along the direction of the signal flow. There are 6 forward paths with forward path gain. Forward path gain 1, RS, A, B, C, D, CS. And the path gain equals to Z2, Z4, Z6. This is the RS, next point A. So this is next point A and the path gain 1. Then A to B, and the path gain G2. Next B to C, and the path gain G4. And similarly C to D, path gain G6, and D to C, path gain 1. Next path number 2, RS, A, F, E, D, C, path gain P2, and the path gain C3, C5, and G3, G5, and G7. So this is the RS, A, F, next point E, and the path gain G5. Next point E to D, and then D to C, and the path gain G7, and last finally 1. So G3, G5, and G7. And forward path 3, RS, A, B, E, D, CS, and the path gain equals to Z2, Z1, and G7. So first RS to A. This is the RS to A path. Next path A to B. This is the A to B and B to E. And the path gain equals to 1, Z1. And E to D, path gain G7, and finally D to C, 1. So forward path 4, RS, A, F, C, D, C, and the path gain equals to Z3. This is the RS to A to F, F to C, and C to D, D to C. Similarly, RS, A, B, E, F, C, D, CS, path gain minus Z2, Z1, H1, Z8, Z6. Similarly, for path gain 6, this is the path gain 6, RS, AFC, RS, A, AF, C, B, E, D, this path, because this is one path. This is the another path. Next, individual path gain. This is also very important. Basic idea. For basic idea, simply RS to A to B, B to C, C to D, D to, this is D point, this path. Next, forward path 1 and path gain already discussed. This is the forward path 2, RS to A to B, F to E, E to D, D to C. This is the path gain and loop. And RS to A to B, B to E, E to D, D to C. And forward path 3 and the path gain G2, G1, G7. And similarly, path gain RSAF D to C, RSAF C D C, and path gain 1, this is 1, this is G3, this is G8, this is G6, and this is also 1. So path gain 6, 4, then 5, RS to A to B, B to E, E to F, F to C, C to D, D to C. And the path gain equals to 1, G2, G1 minus H1, G8, G6, 1. Finally, path 6. This is the path 6. RS, A, F, C, B, E, D, C, S. This is the path 6 and the path gain equals to, this is the path gain, minus G3, G8, H2, G1, G7. So 6 path, forward path and path gain. Then individual loops and loop gain calculation. A closed path in the direction of arrows which terminates at the same node and along which no node is traversed more than once is called the loops or feedback path. A closed path which originates and terminates on the same node and no node is touched more than one. Loop gain, what is loop gain? The product of the gain of all the branches in the loop is called loop gain. And what is the non-touching loops? No common nodes in non-touching loops. And what is the self loop? A feedback loop that contains of only one node is called the self loop. So what is the signal flow graphs idea of self loop? Individual loops and loop gain calculation. First, individual loops and loop gain calculation. From this figure, there are 3 individual loops. There are 3 individual loops. Loops with loop gains. B, this is the point B. This is the point B. B to C direction forward and C to again B. This is the loop and gain minus G4H2. G4H2. So this is the B to C, C to B. And the loop gain G4H2. Similarly, another loop. This is the starting point, this point to again this point, forward direction. And the loop gain equals to minus G5 into H1, G5 into H1. Another loop, L3, and this L3 equals to B to E. So this is the B point, this is E point, this is the F point, this is C point, this is again B point. This is the loop number 3, B to E, E to F, F to C, C to B. And the loop gain equals to G1 minus H1, G8 minus H2. So G1, H1, G8, H2. This is the individual loop gain, loop 1, loop 2, and loop 3. Then step number 8, non-touching loops. There is only possible combination of 2 non-touching loops L1 and L2 and the loop gain product L1 and L2 is, in this case, L1 and L2, this loop and this loop, no touch. That's why these two loops are non-touching loops. And this is the BC to G4H2 gain. And again, these two, F to E and E to F, G5 minus H1. This is the another loop. So L1, L2 equals to G4 minus H1, G5 H2, G5 H2 equals to G4 H1, G5 H2. This is the non-touching loop products L1 and L2. Then step number 9, signal flow graph terminology. Consider a signal flow graph shown in figure 1. This is the figure 1. RS is the reference input, and this reference input may be step, ramp, parabolic impulse, any type of input you can apply. And input or source node, this is also called source node, excitation node, cause node, etc. Then C of S is called the output or sync node, and this is also effect node. In figure, C of S is the output or sync node. Path or branch, this is the very important for signal flow graph. In figure, RS to A is a path. RS to A is a path, and the path gain equals to 1. So first case, RS to A path and the path gain equals to 1. First case complete. Second case, A to B and the path gain G2. B to C, path gain G4. Similarly, C to D, this is the C to D, is a path and the path gain G6. And D to C, path gain 1. And A to F, path gain G3. And F to E, path gain G5. E to D, path gain G7. B to E, path gain G1. And F to C, path gain G8, E to F feedback path gain minus H1. Similarly, C to B, negative feedback path gain minus H2. And A, B, C, D, E, F, these are all chain node. These are all chain node. A, B, C, D, E, F. These are all A, B, C. This is C. This is D. So this is the basic idea of the signal flow graph terminology. Again, for F to E is the path, and this is the G5, and F to C path and the path gain G8, A to F path gain G3, and B to E the path gain G1, E to F the path gain minus H1. Similarly, C to B the path gain minus H2. So thank you.